I don't think about satellites that often. I know they're up there, I know they're doing a lot to make my life possible, but to me, they're floating around in the vastness of space, doing their thing, and that's about it. According to Minu Rathnasabapathy, a research engineer and program lead at the Massachusetts Institute of Technology, I'm not the only one who thinks that way.
So people often think that space is large, and really it is, but we use certain orbits for certain missions. So low Earth orbit, for example, will have a number of Earth-observing satellites, as well as communication and broadband satellites. And each of these orbits have a carrying capacity, which means that there's only so much that orbit can handle.
Low Earth orbit, or LEO, starts at around 160 kilometers above the surface of the Earth, going up to around 2,000 kilometers. And in this area, you'll find the International Space Station and, again, satellites. A lot of satellites. According to one study, there were around 24,185 satellites in low Earth orbit in 2025. And some predict that the number could rise to 70,000 by the end of the decade. And with so many satellites occupying a finite space, you might be wondering, what happens if they crash into each other? Welcome to Tiny Matters. I'm Deboki Chakravarti, and I'm joined by my co-host, Sam Jones. Sam, I have a question for you. Before we started working on this episode, had you ever heard about satellites crashing?
You know, I hadn't. And also, like you, I didn't think about them all that much.
Yeah, well, I'm glad that I'm not alone. I'm glad you're here with me on this journey. But satellites have crashed into each other. On February 10th, 2009, around 490 miles above northern Siberia, a U.S. communications satellite called Iridium-33 crashed into Cosmos 2251, a non-functional Russian communications satellite. This was an area in space that was known to be full of objects, so in hindsight, a crash seemed kind of inevitable.
Which is kind of terrifying in itself.
Yeah, like you don't think about like congestion in space.
No.
There had been other accidental collisions before, but this was the first one to involve such large objects. Iridium-33 was around 560 kilograms or 1,235 pounds, and Cosmos 2251 was around 900 kilograms or 1,984 pounds. So when they hit each other, they produced a lot of debris. NASA reported that the U.S. Space Surveillance Network had found 1,800 new pieces of debris in the orbital planes of the satellites.
So, what is space debris? It's a broad term that includes pretty much any object we've sent into space that's no longer operational, but still orbiting around us.
Once a space mission is over, if the operator isn't proactive in bringing down that satellite, what can usually happen is that it just continues in orbit. So its mission has ended and it's basically now a defunct satellite. But what happens is that oftentimes there can also be collisions in these orbits, which then creates fragments of debris that are continuing to orbit our Earth.
To learn more, we talked to 3 PhD students working under aerospace engineer Heng-Woon Lee in the Space Systems Operations Research Laboratory at West Virginia University.
Yeah, I can start. I'm Matthew Fox.
Yeah, so hi, I'm David Williams-Rogers.
I'm Gavin Baker. So anything we send up into orbit eventually generates some debris in some capacity, whether it's those small chips of paint, some leftover rocket bodies, some old defunct satellites that are no longer serving a purpose.
The European Space Agency's recent model talks about 54,000 space objects over the size of 10 centimeters.
54,000 objects is a lot of objects, but that's just the beginning.
So we have about 1.2 million pieces that are between 1 centimeter and 10 centimeters. So that's about the size of my fingernail to a size of a mobile phone. And we have about 140 million pieces of space objects that are less than 1 centimeter.
Keeping track of those smaller pieces is really tough, which makes sense. But luckily, we do have technology that helps researchers keep track of larger debris pieces and helps us get a sense of what the space debris landscape looks like.
A lot of our detection or tracking is done on ground and in space, where we have, on ground we have radars and optical telescopes, whereas in space we might have some surveillance networks or sensors, as well as analyzing spacecraft that return to Earth and analyzing the damage done to their bodies and using that to kind of back propagate and see what debris they went through and where it was more dense.
And so when you think about just how much of it is up there, you think about the speed that they're traveling, even the smallest piece of debris or space object can do really bad damage to an operational satellite.
These pieces of debris are traveling multiple kilometers per second, so when they hit each other, they're hitting at what's called hypervelocity impact.
If you look at the International Space Station, for example, you'll see on the surface of the station, but also on their windscreens, you'll see pieces of debris that have been hit. In the past year or two, we've seen the International Space Station actually have to maneuver out of the way because there was encroaching space debris that could then, be dangerous to the humans on board on the station.
Gavin broke down the different levels of damage you might expect from debris based on its size. If you're looking at the smallest debris that's smaller than a centimeter, like paint flecks, a collision might create little craters or break through the surface.
Then the next up from that would be that 1 to 10 centimeter range. So from here, if we have a 10 centimeter object traveling at LEO speeds, it's not uncommon for its collision energy to be similar to that of 7 kilograms of TNT. And so we start to look at some pretty serious fragmentation and some damage and possibly even lethal damage to our satellites or assets in space.
Okay, I feel like even the stuff that is less than a centimeter is wild to think about. And then the fact that something that's just 10 centimeters could cause that much damage, I can't.
It's really scary to think about.
It's really scary.
And it gets even scarier when you get to objects that are larger than 10 centimeters.
Where we're looking at almost complete and total destruction, complete lethality, and complete fragmentation of everything involved in that collision.
Not great.
Nope.
It's helpful that we can keep track of larger pieces of debris because if an active spacecraft has a propulsion system, then operators can maneuver it out of the path of oncoming debris. But that's not trivial. Here's David.
The larger debris, it's a threat because it's both the main source of new debris in case of a collision, and also because it costs money because it forces operators to change active spacecraft orbits. And this change in orbit to avoid a collision might lead to also loss of the mission objective. We might miss the target that we were interested in because we were forced to relocate to a new orbit to avoid a collision.
And as David just mentioned, collisions from space debris create more debris. And of course, that can then cause more collisions, which creates even more debris. Scientists call this the Kessler Effect. And as we get more satellites in low Earth orbit, the likelihood that this chain reaction of collisions could lead to an unusable orbit increases, which means no more satellites can be placed there.
There are also concerns around our safety here on Earth. Space debris can descend through our atmosphere, but it should burn up before it gets to our surface.
However, if the pieces of debris are too large to burn up in our atmosphere, we do see them falling. We've been lucky that no humans have been hurt, but there has been property damage that has been recorded. And so it's not a big concern as yet, but certainly as we see the numbers of debris increasing, especially in low Earth orbit, the risk to human life is not insignificant.
Plus, the satellites we've sent up to space are there for a reason. They're part of our daily lives, even if you're like me and you don't always appreciate it.
Or like me and you don't understand it either.
Whenever we ask our phone for directions or look up the weather, we're relying on satellites. So it's really important to figure out ways to minimize both space debris and the damage it can cause. Debris, of course, sounds a bit like litter. And what do you do with litter? Pick it up.
scientists are exploring different strategies to do so in space. Though, of course, there aren't trash cans out there to throw the debris in. And actually, if there were trash cans out there, that would count as debris. So some ideas are to send small enough debris into our atmosphere to be burned up, or to shunt it to a graveyard orbit that's further away from Earth, which is where old satellites are sometimes sent so they can't create more debris. And so to make these approaches possible for debris removal, there are a few technologies being designed. Here's David again.
Some of them include robotic arms, where spacecraft are going to be equipped with a robotic arm, and they are going to perform a proximity maneuver. That means that we want to be as close as possible to the target debris that we are aiming to remediate. We are going to grab it and move it to a location that we know is convenient.
There are also nanotags, where the spacecraft still approaches the debris.
But in this case, it's going to release a swarm of nanosatellites, each of which is going to be equipped with a propulsion system that they are going to go and attach to the target debris, and they are going to move this debris towards the graveyard orbit.
And then there are contactless methods, like using lasers to shoot at debris, which sounds straight out of a sci-fi movie. Like, this is definitely Star Wars coded. Though, in reality, you're not actually blasting the debris into nothing. This technique is called laser ablation, where you shoot a focused laser beam at an object, which then vaporizes a small bit of the surface into a plasma plume, shifting the debris into a different path. These lasers could be based on Earth, but the members of Hang-Woon Lee's lab are studying the idea of placing multiple lasers in space that work together to take on debris.
I mean, how could you say no to space lasers?
That's a good question.
Yeah.
One of the reasons why lasers are a great solution to space debris is that they're relatively cheap. Here's Matthew explaining some of their advantages.
So since it's not the contact-based method where we need to be in very close proximity, if we have a specific specification on the laser platform that allows us to engage at a large distance, then we can do that. We can also engage at a short distance. We can engage from anywhere around the debris, around like a spherical shell around the debris, to be able to move the trajectory in the orbit of the debris.
But as we talked about, there's a lot of debris up there in LEO. So much of the work being done now is to figure out where these lasers could or should go to have the most impact. They're also working on figuring out how autonomous this system can be, so to what degree a human should be involved to make sure it runs smoothly. This challenge is further compounded by the fact that we can't know everything we need to know about a piece of debris before targeting it.
Maybe we don't know if it has some empty cavity inside of it. If it's aluminum, maybe it's multi-layer material that has a different ablation across the surfaces. Maybe it's a sphere, maybe it's an irregular object that's spinning oddly.
The work for designing the space-based network of debris-removing lasers is currently being done in simulations, though they're able to draw on experiments that others have done to inform these models.
And more on that in just a moment. American Medieval is a podcast about the Middle Ages, but with an American twist. Every week, Professor Matthew Gabriel is joined by an expert scholar to talk about either some bit of the medieval world itself or how Americans have, throughout our history, used the Middle Ages to say something about ourselves. If America has never been fully modern, it might be because we've always been a little bit medieval. New episodes are available every Wednesday. So subscribe to American Medieval in your podcast app now. That's American Medieval from the Multitude Podcast Collective. All right, back to the show.
It's important to remember that there are challenges beyond just the technical feat of being able to remove space debris. For one, these technologies come with a cost, both to develop them and to implement them. Space isn't cheap.
There's also the question of who should be doing this removal. In our recent episode about deep sea mining, we talked about an idea that guides a lot of regulations around the deep sea, which is that the resources of the ocean should be managed for the good of humankind as a whole. In that episode, we were talking about extracting polymetallic nodules, but there's a way that these deep sea questions parallel those related to dealing with orbital debris. Matthew told us about the Outer Space Treaty, which sounds very cool, and also was adopted by the United Nations in 1967 and has, at least as of 2024, been signed by 115 countries, including the United States. This agreement calls for our use of outer space to be done for the benefit of all countries and for all mankind. And Article 7 of the Outer Space Treaty holds countries liable for damage caused by the objects they launch into space.
So when we talk about potentially deorbiting, remediating, even nudging specific orbital debris, that liability is shifted towards the government that created the debris in the first place. So we run into a tricky situation there in the geopolitical landscape of should one nation really be able to start to nudge around and move certain debris that isn't their own? And if they do and some collision happens, what is the result of that? Who takes the onus on that type of result?
The United Nations has continued to develop policies around space with the goal of making our collective use of it sustainable. Minu told us that one of the biggest UN committees is the United Nations Committee on the Peaceful Uses of Outer Space, or UN COPUS, which meets 3 times a year.
What's interesting with UN COPUS is that it is completely done by consensus basis. So whether you are a long-term heritage country or you have just sent your very first satellite into space, or maybe you don't even have a national satellite as yet, everybody's vote is the same. And so UN COPUS is really the key organization that comes together to put guidelines and policies and help guide these conversations for the future.
That consensus vote is amazing for making sure that more people can have a voice in the conversation. But of course, it can also be really hard to come to consensus. For one, the geopolitics that shape the relationships between countries on Earth can extend into these conversations about space. And different countries are operating at very different levels when it comes to space. Minu studies space sustainability, and one of the concepts that's important to her work is called the pacing gap.
We're seeing an increased number of launches because launch costs are decreasing. And so every country and every commercial organization wants to put up a satellite and call it their own. But at the same time, policies and regulations can be quite a slow, iterative process. So this pacing gap is sort of defined as this mismatch of time and scale in the conversation around space sustainability. And so what I'm really interested in and the questions that I ask are, how do we bridge this pacing gap and how do we slow it down so that, new entrants, whether it be Malawi or Mauritius, who are just now launching their first satellites, have the same accessibility and equitable use of space as some of the countries that have long had heritage, such as the US and Russia and China.
In 2019, COPUS adopted the guidelines for the long-term sustainability of outer space activities. In total, there were 21 guidelines covering everything from policy frameworks for space activities to scientific research.
It took 10 years for the committee to come to a consensus on these 21 guidelines. So, thinking about, again, all of the technology that was developed over the course of that decade, and yet the slow, incremental, and it has to be slow and incremental in consensus basis, but that juxtaposition of timescales is really incredible when you think about even just developing some guidelines for countries to pursue space sustainability.
And as you can imagine, space technology evolved a lot over those 10 years.
What we've seen in the past few years is that because some of these bureaucratic ways can be quite slow, industry and commercial actors have actually come together to put together their own industry-led standards and regulations that they themselves are signing up and abiding to. That takes into account a lot of the technology development that would otherwise be slow to incorporate in some of these bigger UN bodies, for example.
That's so interesting. Do they ever contradict?
Great question. It's actually a topic of a research paper that I'm currently writing, which is, you see some companies signing up to some industry standards and not signing up to others. So again, trying to find a sort of blanket solution is going to take time, but we don't necessarily have that time with evolving technology innovation. So it's striking this balance of how do we come together in a unified way to ensure, both on a commercial side, but also on a governmental side, this long-term use of space. And that was really what inspired the evolution and development of the space sustainability rating.
The Space Sustainability Rating is a voluntary system used to rate how sustainable a mission or satellite is. Minu worked on it, and she compared it to things you've probably seen in other industries, like the LEED rating system, which is used to assess the sustainability of a building's design, construction, and operation. The idea for a space equivalent was born at the World Economic Forum.
And we had a group of experts come together, and we realized actually there isn't one definition of what sustainability in space is. And there's certainly no metrics to define what that is. And as an engineer, I got to say, I am all about quantrics and thinking about how you can't manage something that you can't measure. And so we came up with this idea. It took quite a number of years and a transdisciplinary team consisting of MIT, the University of Texas at Austin, Bryce Tech, the World Economic Forum, the European Space Agency, and the EPFL Space Center to really come up with these different ways of scoring missions, but also thinking about what those scores would mean eventually. And again, coming back to that, how do we incentivize different actors to score the highest, but also be rewarded for their high scores?
There are a few different parameters that go into the space sustainability rating. For example, what is the risk that your satellite might be added to a congested orbit? Are you sharing the location of your satellite with others to help prevent collisions? Are you complying with international standards and guidelines, whether those are voluntary or mandatory? And while active debris removal is still super new, and not all satellites will require it, there are bonus points for missions that are pursuing strategies around it. And that all gets thrown together to come up with a final score.
So very similar to the LEED rating system of buildings, we have a tiered system that consists of bronze, silver, gold, and platinum. Operators can choose whether they want to publish their rating. Again, it's voluntary. So, we often encourage them that even if they have a bronze rating, it's still showing a commitment to space sustainability and optics-wise, to their other peer groups and other operators, really showing what they are doing in order to push on that topic.
Missions can last for a long time, sometimes even decades. So the rating isn't static. It's meant to be renewed to take into account the way that operators may change their approach over time. The goal overall is to really incentivize these operators to pursue sustainable projects in space.
So we've been lucky enough to have champions of the space sustainability rating who have been there from the very beginning, who've gone through our beta testing process, now all the way through to being rated themselves. And what we found is that even just the optics of being rated are really compelling to actors. We are working on the incentive side of the rating system. So thinking about how we can work with space insurance companies to reward operators who are getting platinum or gold ratings. We also have, a system where in case an operator receives a bronze rating system, we work with them to identify what actions they can take in order to raise their tier up.
Can you tell me more about space insurance?
Do I have to?
Debogi, I'm just wondering who asks about insurance?
Usually not me. I had just never heard about space insurance being a thing before. I'm pretty sure that like all insurance, it's actually very complicated and boring.
Yeah, even though space is so interesting, I think the way that you make it boring is by talking about insurance related to space.
With all apologies to our insurance listeners.
Yeah, sorry.
One of the other things that stood out to me when I was reading your papers was you noted that like the education for space mission engineers like doesn't really emphasize sustainability. That really struck me just like thinking about my own engineering background, where I felt like we never really were taught about the broader impacts of the kind of things we were working on. And so I'd love for you to expand on that. Like what do you think a meaningful approach to education in this area would look like?
So if I look at my own engineering degree, certainly space policy did not come into that at all. It was such a technical degree. But I had this opportunity working with an organization that supported the UN a few years ago to really immerse myself in these conversations around space sustainability at the UN. And it came as quite a shock to me that, all of this policy and space law was out there, and yet the engineers and the scientists weren't privy to that. And quite honestly, it's a missed dialogue. We don't often speak the same language. So really incorporating both technology and policy as well as sustainability in these conversations, but also courses, I think just opens people's minds up. So as an engineer, how do I consider while designing my next satellite, how these policies are going to impact that mission? Or how do I consider the policies from the very get-go rather than thinking of them later and having to amend my designs or amend my operations, because now I do have to abide by those policies.
Sam, I want to take a bit of a left turn and connect what Minu just said with a moment that stuck with me from my interview with David, Gavin, and Matthew.
Go for it.
Is there something going on in your field? Maybe not even just space debris, maybe like space in general, like that's been really exciting for you.
Yeah, I would say Artemis mission, like the very short, that was amazing. Like we were working on the lab and we would like stop working and start looking at the live transmission and like commenting on there.
Yeah, I think it's Artemis far and away.
Yeah, I feel like going through it, I keep having the broken record response, but I feel like we're in the second big stage of space exploration. We started with Apollo for the U.S. And with the resurgence of the Artemis mission. It's just amazing to be able to say that we're able to take a part in space exploration at this point in time.
I think about that a lot too. Like, I think the way that many of us are feeling right now mirrors, or I think gets the closest that it could to how people were feeling around Apollo over 50 years ago.
Right. Yeah. And so like this episode ended up being part 2 of a series that we didn't plan to do about space safety.
Yes.
But here we are. In our last episode, we talked about the Challenger disaster and how that informed safety on the Artemis 2 mission. And yeah, I just really wanted to take this opportunity to talk about Artemis again, because like you said, it's like the cool space news of our time. And I think it's just made a lot of us feel really connected over this incredible achievement, even if we had nothing to do with it.
Yeah.
But also in the context of this episode, I feel like Artemis is this reminder that space is becoming accessible to us in so many ways.
So one of the things I'd like to leave your listeners with is just thinking of space not as this huge expanse, but really bringing it closer to here on Earth. As I said, we rely so much on space technologies on an everyday basis that our orbits are now an extension of Earth's critical infrastructure. So just as that we would take care of our roads and our oceans, we also need to be taking care of these really critical orbits.
Okay, Deboki, let's tiny show and tell. And I want you to kick it off because I think I know what you're going to cover. So for context for our listeners, as we were quickly going through the episode before we started the recording, Deboki said, "Oh my gosh, there's science news. I need to switch my tiny show and tell for today." And I'm pretty sure I know exactly what it is, and it's very much related to this episode, and especially the end of the episode. So, Deboki, do you want to kick this off?
Thank you. Thank you for leading me off perfectly. We will talk about how a flu drug might be able to prevent cognitive decline in HIV in a future episode. But today, we're going to talk about Artemis 3 because NASA just announced the astronauts who are going to be going on this mission, which is so exciting.
And Deboki, I have not looked it up because I wanted to real-time react to the things that you are saying.
Cool. Awesome. Perfect. So NASA just announced the 4 astronauts who are going to be going on this mission. It's slated for the end of 2027. It might launch a little bit later. These things don't always go according to schedule, but that's for future us to learn. So there are 3 astronauts on this mission from NASA. They're Andre Douglas, Frank Rubio, and Randy Bresnik. And then there's an astronaut who is astronauting on behalf of the European Space Agency, and that's Luca Parmitano. And then there is also a backup crew member who is a NASA astronaut named Bob Hines.
Cool.
Yeah. So they are scheduled to launch, like I said, at the end of, or the second half of 2027. And this is going to be a test flight in low Earth orbit, which we've been talking about a bunch today. They're going to be spending around 2 weeks in the Orion capsule. And one of their goals is going to be to link up with these human landing system vehicles. And this is a part of building us up to our future Artemis mission. So including in late 2028, there's a plan to return to the moon on Artemis 4. They'll also be doing a spacewalk, or at least that's part of the plan on Artemis 3. And they'll also be testing out the latest spacesuits, which were designed by Axiom Space and Prada.
Whoa.
Yeah, some fancy
astronauts.
Yeah. I really want to talk to the Prada crew that's working on this. I really want to know what that collaboration is with Axiom Space.
I do too. Yeah, that's fascinating.
We're going to do a future space fashion episode.
Actually, yeah, that would be pretty neat. I would actually really like that, thinking about the materials and what you actually need.
I feel like the engineering there must be really cool.
Yeah, I would think so. Well, Deboki, thank you. This is exciting.
Yeah, I'm so curious what the build up and everything for this launch is going to be like. Are we going to be more excited and invested because we've come off of Artemis 2? So even if we won't get necessarily all the same moon stuff, we're still going to get astronauts and the progress and everything. So I'm really excited.
Yeah, absolutely. And a spacewalk is really cool. So I think, I don't know, it's not the same. You're not going to get the, Earthrise image and all of that, but I think it's still going to be so cool.
Yeah.
Well, I have something not related to that at all.
Perfect.
And it's brief, but essentially I came across this because I thought that the footage is really interesting and people might want to check it out. And so I will, of course, we'll link to it in our sources, but it's about giant fire tornadoes, which sounds scary, but actually they're being used for a really important purpose.
So they're not scary.
So they're scary if they're not sporadic, spontaneous. We are setting them.
Got it.
Right?
You keep saying these things as if they make them less scary.
Yeah. We're setting them to clean up offshore oil spills.
Okay, cool.
That's the purpose behind them, right?
Fascinating.
So there are a number of ways that different agencies, scientists are trying to clean up oil spills. There are a bunch of different methods right now. Obviously, none of them are incredible because we're still looking for other options. And so one that I saw something published about just a couple months ago, but then it kept resurfacing in different things I was seeing the last couple of days, is that there have been the first large-scale experiments that are actually showing that these, quote, giant fire tornadoes, they call them fire whirls, they seem to burn oil spills a lot faster than the more traditional methods, which include fire pools, which my understanding is it's just kind of trying to aggregate all of the oil that would be on the surface of the ocean and then light that on fire. So it's actually creating this whirling tornado. And so there's a very cool experiment they did that's obviously well controlled. Like I'll send a link so you can see the video, but you see the tornado motion, and they found that I think it's the fire whirl produced 40% less soot and consumed up to 95% of the fuel, which is great because if you're not cleaning up a lot of it, then there can be, harmful chemicals, or, you have these long chains that get broken down, and really like toxic residue is left behind in the environment for a very, very, very long time.
Yeah.
And so I just thought that this was so cool.
Yeah.
The research was led by Texas A&M University, as well as a lab at UC Berkeley. The one that they used in the experiment was 17 feet tall, which is not actually that tall. Like, it would be a lot taller in nature. But yeah, I just thought this was really cool.
Yeah, that's amazing.
Like I mentioned, the soot emission was cut by 40%, burned up to 95% of the fuel, but it burned it 40% faster.
Wow.
And so like that's the other big thing is it's way faster having that for some reason. I mean, they get into it. If you really want to dive into it, they get into like why it is that they think that swirling motion of the tornado really makes it so much faster than if you just have this pooling. Yeah, I just thought it was really cool. And physics is neat.
Yeah. Tornadoes, not scary.
Yeah.
Or fire tornadoes, not scary. Tornadoes, scary. Fire tornadoes.
Fire tornadoes deployed for a purpose on the surface of the ocean, not that scary.
Yeah. Amazing. Cool.
Yeah.
Well, thank you, Sam. And thanks for tuning in to this week's episode of Tiny Matters, a podcast brought to you by the American Chemical Society and produced by Multitude. This week's script was written by me and edited by Michael David and by Sam, who is also our executive producer. It was fact-checked by Michelle Boucher. Our audio engineer is Misha Stanton. The Tiny Matters theme is by Michael Simonelli and the Charts and Leisure team.
Thanks so much to Minu Rathna Sabapathy, Gavin Baker, David William Rogers, and Matthew Fox for joining us. Go rate and review us wherever you listen. We super duper appreciate it. Also, remember, if you have an episode idea, feedback, etc., email us tinymatters@acs.org, and we'll see you next time.